Hello students, welcome back to my YouTube channel. This is Kashima Soni and today we are going to take up the next part of our series mass spectrometry that includes the another two most important mass analyzer techniques, that includes your quadrupole mass analyzer and another one is time of sector mass analyzer. Time of flight mass analyzer. Okay, so before jumping to that particular topics, I would like to make a request to you all people to just check the links that I mentioned in the description box. That includes all of your mass spectrometry videos that I've uploaded till date, and I request you to just switch to that portion first and then come to this part of the series. Okay, so that would be quite understandable for you as well. Okay, so without wasting any more time, let's proceed further to our rest of the two mass analyzer. First one being quadrupole mass analyzer, and that is over here. Okay, so what is happening in this particular case? A set of four solid rods are actually arranged parallel to the direction of your ion beams that you can see in the previous slide over here. See, okay, over here you can see. Let me change the color of the pen first. Okay, so over here you can see the set of four solid rods are actually arranged parallel to one another in the direction of your ion beam. Okay, and all of these rods, you should keep this in mind that they should be hyperbolic in cross section, although you can also use cylindrical rods. So yeah, that is one thing. And next is you should be applying DC current, that is a direct current voltage, and radio frequency is applied on the rods, so it will be generating a electrostatic field, okay, in between these rods. So in this in between the region of these rods, what is generated now? Electromagnetic, or you can say, sorry, not electromagnetic, electrostatic field is generated via your DC voltage or RF, that is radio frequency. Okay, so one thing, that is your generation of your electrostatic field in the region between the rods. So now what is happening after that? See, we have discussed these 2 points. That in first point, what is happening? We have used a solid four rods that is arranged parallel to the direction of beam. DC and RF is applied to the rods, generating oscillating electrostatic field in between the rods. Now, depending upon the ratio of radio frequency amplitude to the DC voltage, your ions are going to acquire an oscillation in that पर्टिकुलर इलेक्ट्रोस्टैटिक फील्ड, जो कि आप वीडियो में देख सकते हो, इस डायग्राम में देख सकते हैं आप कि जितनी आपकी आरएफ, दैट इज योर रेडियो फ्रीक्वेंसी एम्पलीट्यूड, और डीसी की रेडियो फ्रीक्वेंसी टू डीसी की जितनी आपकी रेशियो है, उसके वो किस पे डिपेंड कर रही है? उसके ऊपर आपके आयंस की ऑसिलेशन डिपेंड कर रही है इन बिटवीन दीज रॉड्स. ओके, सो आपकी जो आयंस की ऑसिलेशन है, इट इज एक्चुअली डिपेंडिंग अपॉन रेडियो फ्रीक्वेंसी एंड डीसी वोल्टेज. ओके, दैट इज अनदर थिंग एंड अनदर इंपॉर्टेंट थिंग. सो यू शुड कीप दैट पर्टिकुलर थिंग in your mind. What is happening? Depending on the ratio of radio frequency amplitude to the DC voltage, your ions are acquiring an oscillation in the electrostatic field. ठीक है, अब देखो होगा क्या, जिन भी आयंस की इनकरेक्ट मास बाय चार्ज रेशियो है, या फिर उनकी मास बाय चार्ज रेशियो इफ इट इज extremely small or if it is extremely large, they are going to have an unstable oscillation. ओके, उनकी ऑसिलेशंस प्रॉपर नहीं होंगी एंड विच इज वाई वो डायरेक्ट आपके डिटेक्टर में नहीं डिटेक्ट होंगे. अंडरस्टैंडिंग? सो दैट इज अनदर थिंग. So ion of your correct mass by charge ratio, they undergo actually stable oscillation of constant amplitude and travel down your quadrupole axis like this with a corkscrew type trajectory, and it will directly be detected in your detector like this. So you can see this is your ions that have been traveling like this, and these are the ions that have been mentioned outside your cylindrical rods. These are the mass by charge ions of mass by charge having incorrect ratios, and either too large or too small, which is not going to reach your detector clearly. So that is about the setup of your quadrupole mass analyzer. Okay, so that I have already mentioned, that ions of incorrect mass by charge ratio, they will be showing unstable oscillation, while that of your correct mass by charge ratio, they will be showing stable oscillations, which is now get detected via your detector. Okay, so like the magnetic sector mass analyzer, this quadrupole, it can be scanned from your high to low values of mass by charge. That is another thing. Okay, so over here you can see another that diagram. But before talking about that particular diagram, I would like to add on few points related to quadrupole mass analyzer. See, this mass spectrometer, that is your quadrupole mass spectrometer, are actually low resolution instruments. So let me write it for you. These are actually low resolution instruments. Over here I will be writing low resolution instruments having resolution at around 3000. Okay, and they are actually incapable of providing the exact elemental composition of the sample, but their relatively low cost makes them quite popular for any of other applications. Okay, so that is one point that I wanted to add. Having low resolution, it is not that much capable of all of your exact elemental composition detection, but due to its low cost, it is quite useful in many other applications, and it has a drawback also, that is its relatively slow acquisition rate due to their scanning nature. Slow acquisition rate due to scanning nature. That is about this quadrupole mass analyzer. So over here you can see this diagram. That is the diagram of your quadrupole ion trap mass analyzer. That is this one. Okay, this one is your quadrupole ion trap mass analyzer. Okay, see what is happening. This mass analyzer will be operating by the similar principle as your linear quadrupole mass spectrometer that we have discussed in the previous slides over here. And what is happening, this ion trap, it is actually consisting of your two hyperbolic end, this one and this one, you can see. Okay, so it is consisting of your two hyperbolic end cap electrodes, जिनकी आपके पास जिनके बीच में आप देख सकते हो डोनट शेप्ड रिंग इलेक्ट्रोड्स है. दैट इज योर एंड कैप इलेक्ट्रोड. ओवर हियर यू कैन सी इट इज क्वाइट मेंशन्ड. दिस इज डोनट शेप्ड रिंग इलेक्ट्रोड. दैट इज over here that I've already labeled. Okay, now next is what is happening. जो आपका alternating current है AC, or you can also use DC, and radio frequency potential is applied in between these end caps. Okay, over here RF and what else? RF and AC or either DC is applied between the end cap and the ring electrode. So that means over in between end cap electrode and in between this ring electron has been applied your AC radio frequency potential. Okay, so that is one thing. Now what is happening in the linear quadrupole analyzer? What happened? Ions of different mass by charge values, they are allowed to pass in turn through the quadrupole by actually adjusting the RF and DC voltages. तो जो हमने पीछे आपका देखा था आपके लीनियर क्वाड्रुपोल सिस्टम जो हमने पढ़ा था, उसमें क्या था कि जो आपके आयंस हैं जिनकी डिफरेंट मास बाय चार्ज रेशियो है, सबको अलाउ किया जाता है टू पास टू दैट पर्टिकुलर क्वाड्रुपोल रीजन बाय, आप एडजस्ट किसे कर सकते हैं, बाय एडजस्टिंग द आरएफ एंड द डीसी वोल्टेजेस. ओके, दैट इज वन थिंग. आयन ट्रैप में क्या है, ions of all the mass by charge values are in trap simultaneously. मतलब सभी के सभी ions जिनकी अलग अलग mass by charge ratio है, they are actually all of them are trapped simultaneously and वो oscillate कर रहे हैं in your concentric trajectories. Okay, that is one thing. So आपको समझ आ रहे हैं यहाँ पे हो क्या रहा है exactly. यहाँ पे आपके जितने भी ion trap में क्या होंगे, सारे के सारे ions actually they are trapped simultaneously. So that is why the name, that is your quadrupole ion trap mass analyzer. अब होगा क्या, what is the thing that you are going to do, that is the sweeping your radio frequency potential. It will result in the removal of your ions with increasing mass by charge values. ठीक है, क्या होगा, जैसे जैसे आप RF पोटेंशियल की वैल्यू आइदर इंक्रीज स्वीप करेंगे थोड़ी सी भी, इफ यू आर स्वीपिंग द RF पोटेंशियल, इट रिजल्ट इन द रिमूवल ऑफ आयंस with increasing mass by charge value by putting them in unstable trajectory. Okay, and what is happening, they are now causing them to get ejected. You can see over here these ions are getting ejected, and from the trap they are getting ejected in the axial direction towards your detector like that. Okay, so these ions have now reached your detector like that. So what is happening, this particular process where the sweeping of your RF potential, it is resulting in the removal of ions of with the increasing mass by charge value, it leads to the unstable trajectory, और जिसकी वजह से क्या होगा, आपके ions eject हो जाएंगे, and after ejection they are going to get detected in your detector. Okay, so this whole process is known as resonant injection. Okay, और आपका ये जो प्रोसेस है योर क्वाड्रुपोल आयन ट्रैप mass analyzer, it is actually quite sensitive as compared to linear quadrupole instrument. Okay, so that is one thing happening over here. अब देखो आगे क्या होगा, बिकॉज ये जो आपका आयन ट्रैप है इसमें सभी के सभी आयन्स होते हैं आपके पास, ऑलमोस्ट of all ions are present having various m by z value at the same time. होगा क्या यहाँ पे, जो आपके आयन ट्रैप मास एनालाइजर हैं दे आर आल्सो सेंसिटिव टू ओवरलोड एंड आयन मॉलिक्यूल कोलिजन, ठीक है, जिसकी वजह से आपके स्पेक्ट्रम में कुछ डिफिकल्टीज आ सकती हैं, बिकॉज देखो आयन ट्रैप मतलब सभी के सभी आयन्स इकट्ठे ट्रैप हुए पड़े हैं यहाँ पे, ठीक है, आयन्स आपके सभी इकट्ठे ट्रैप हुए पड़े होंगे, विच इज वाई यहाँ पे ओवरलोडिंग के चांसेस हैं, एंड ओवरलोडिंग और आयन मॉलिक्यूल कोलिजन की वजह से आपके स्पेक्ट्रम में डिस्टर्बेंस शो हो सकती है, कॉम्प्लिकेशंस शो हो सकती हैं, ठीक है. सो दैट इज वन थिंग ओवर हियर. So recall, you should remember that your not all of the sample get ionized. आपको पता है कि कुछ sample आपके as such neutral रहते हैं, they remain uncharged. Okay, so these neutral species they are now moved down in the ion trap, resulting in the collision with the ions, and they result in this some sort of stable trajectories. अब क्या होगा कि ये collisions जो होगी, it result in the some sort of self ionization. Self-chemical ionization. You can see over here, your fragment ion RH plus is reacting with your neutral molecule, result in the formation of your R new neutral or radical molecule and N plus H positive protonated molecular ion. So that is one thing. So result is abnormally large M plus H positive peak in the mass spectrum is observed, that you can see in the figure 3.15. Okay. So what is happening? You can see at 215 over here, this is this one is representing your M plus H positive value. So this is happening all because of your ion trap. Okay, let me get back to that particular thing. Yeah, so this is happening actually because of your quadrupole ion trap mass analyzer, okay, which is leading to your self chemical ionization technique. So that is all about this particular method, and I am stopping this video over here only. The last method, that is your time of flight mass analyzer method, will be discussed in the upcoming video that I am going to upload most probably today or tomorrow only. So yeah, that's all about this particular series of your mass analyzer having third mass analyzer in it, that is your quadrupole mass analyzer. And that's all about it. Thank you for watching. Do like, comment, share the link, subscribe the channel, and do not forget to press the bell icon for more updates. Thank you.